Hey guys, how's it going today? So today I'm absent, but we still get to go through some of the material that we need for this unit. So far we've talked about stars, we've talked about other objects in the solar system, most notably planets, and today we're going to look at some of the smaller objects in our solar system. We're going to look at what they are, what they're made of, where we might find them, and if any actually have any sort of bearing to life here on Earth. So, without further ado, let's start talking about smaller objects in the solar system. First type of object we're going to talk about are comets, but before that, before we get through this presentation, you should be able to describe the origin and structure of comets, identify differences between comets, asteroids, and meteoroids, discuss asteroid-meteor impacts and their possible effects on the Earth. So, with that being said, let's start talking about comets. You can see in the picture there are different parts to a comet, but what exactly is a comet? So, a comet is basically composed of dust, rock, and particles of water and ice. And so, what happens is that they form at the very edge of the solar system, and as they come closer to the sun, that ice first starts melting and then vaporizing, and some of the solid matter actually vaporizes as well. We'll talk about that more in a second. So the most famous comet you've probably heard about this is Halley's Comet, and it was discovered by astronomer Edmund Halley. And he was the person that kind of put forward the idea that, wait a second, this comet that I'm looking at now, I think it's the same comet that was here 76 years ago. And he was right, so he got a comet named after him. So the last time Halley's Comet visited us was in the wonderful year of 1986. I was 9 years old, and the Mets just won the World Series. So it was a good year, but it seems like the Mets aren't going to win another World Series until Halley's Comet comes back. And it is scheduled to come back in the year 2061. So hopefully you guys are around to see that. That is only 41 years away. Hopefully I'll be around to see that. I will be 84 should that happen. So, Halley's Comet, possibly a once-in-a-lifetime experience, twice in a lifetime if you're lucky. Comets primarily in our galaxy, in our solar system, start off in the Oort cloud. We didn't talk much about the Oort cloud, but right now it's thought to exist. We have a lot of evidence that suggests it might exist, but we think it's basically a cloud of icy material, rocky material, dusty material, and it was named after a Dutch astronomer named Jan Oort. That makes sense, right? We name a cloud after him, and we'll give it his last name. Okay, so we think that this cloud is a cloud that surrounds our solar system at the very edge, and again, it's made up of rocky and icy and very tiny particles. Right. So what happens is, of course, everything in our solar system is gravitationally attracted to the sun being the largest thing in our solar system and the one with the most gravitational pull. So what happens when it starts interacting gravitationally with the sun and maybe even possibly other nearby stars is it gets knocked out of the Oort cloud and it starts making its way towards the sun. So it's moving at a very, very high rate of speed, getting closer and closer to the sun. So as it gets closer to the sun, of course, it's exposed to higher and higher temperatures. Okay, so here we take a look at a three-dimensional image of our solar system showing where we think the Oort cloud exists. If you look in the center, that's where we'll find the sun. And as you move outward towards the very edges, that's where you're going to see the Oort cloud. And you see a scale there showing you how many astronomical units. That, remember, the astronomical unit was the average distance between the sun and the earth. So how many astronomical units our entire solar system is? As you can see, our solar system is, to put it mildly, really, really, really big. All right, let's look at the parts of the comet, including the nucleus, coma, and tail. So the nucleus is basically the very center of it, really where all the material is, up until it gets close enough to the sun where material starts to vaporize. Or to use a chemistry term, it sublimates. Bonus points if anybody knows what the term sublimation means. I'm going to ask the same question in class tomorrow, by the way. Okay, and because what's happening is this stuff is melting, it's vaporizing. It's going to happen in the direction opposite to the movement of the comet. So the movement of the comet is towards the sun, and so the tail, as it's breaking off and melting off and vaporizing, is going to go away from the motion of the comet. So it always points away from the sun. So eventually, a comet's water and ice vaporize completely, and this is after many trips around the sun. So we think Halley's Comet is going to be visible about every 76 years for quite a while. Because what happens is it vaporizes and then makes its little turnaround as it passes the sun, and then goes back out to the Oort cloud, and it gathers more dust and rock and ice, and comes back rejuvenated in 76 years. Now, sometimes small particles break off. They don't completely vaporize immediately. And we can actually get some of this traveling through Earth's atmosphere. And when that happens, it gives us some spectacular meteor showers. And just to give you an idea of what that might look like if you were seeing it, the picture on the right is actually an artist's rendition, but the picture on the left is of a real meteor shower. And you can sometimes see those looking up when we are visited by a comet or even a meteor that has pieces break off in the sky. So, asteroids, guys, let's talk about those. So, asteroids are basically space rocks. Okay, they're small particles, or they're small in comparison to things like moons, and they break apart, and we call those meteoroids. Okay, the parts that break off, they're called meteoroids. They're small particles of asteroids, or comets for that matter, actually. That's why we can call the shower that we see even from a comet a meteor shower. Okay, but the term meteor actually specifically refers to the light given up or given off as it burns up in the atmosphere because there's so much friction that it encounters between the air molecules. It pretty much usually almost everything coming through our atmosphere pretty much burns up before it can hit the ground. Okay, by the way, meteors are also referred to as shooting stars. So that's what you're actually seeing when you see a shooting star in the sky. Now, meteorites, they're something else entirely. Those are rocks that actually survive. So after that burn, it was large enough so that something survived and made it to the ground. And this is where we have meteorites. Guys, if you want to learn more about one of the more famous meteor strikes in recent history, check the link on the screen right now. Moving forward, the Barrington Crater, probably the most famous impact site for a meteorite in the United States. It's a mile-wide crater that formed when a meteor about the size of a house impacted in what is now Arizona. Obviously, it was a while ago, before Arizona was a state, before the United States was a country. Now, asteroids are pieces of rock that are actually very similar in material makeup to the terrestrial planets in the solar system. They just don't have the mass and quite often the shape to be considered a planet. Or I should say the size and shape. Typically, like I said, much smaller than even moons. Most of them are going to be located in the asteroid belt we learned about yesterday between Mars and Jupiter. Okay, remember we said that there was an asteroid belt between Mars and Jupiter that almost acted like a border between the terrestrial planets and our gas giants or Jovian planets. Now, there is thought in astronomy that Earth is pretty fortunate and we are pretty protected whenever asteroids come our way, because Jupiter actually has a much larger gravitational pull and tends to deflect a lot of meteors away from us. Doesn't deflect everything, but pretty much keeps us relatively safe for long, long periods of time. All right, so now we're going to get into kind of a gray area here. So where do we stop calling it an asteroid and start calling it a dwarf planet? Ceres, much like Pluto, is a dwarf planet, but once upon a time we considered it an asteroid. But because of its round shape and the fact that it is relatively large compared to most other asteroids, we now consider it a dwarf planet. By the way, talking about asteroid impacts, well, first of all, most asteroids range in size, and there's a huge range here, between 1 and 940 kilometers in diameter. But as I said, for the most part, we are largely protected. Here are examples of some more famous asteroids in our solar system. Technically, on the left, you'll see Phobos and Deimos. Those are technically considered moons of Mars. All right. So if you guys want a little bit of perspective on the size of asteroids, one of the more famous ones to happen in recent years happened in Russia. And when it impacted with the ground, or just before that actually, it exploded. And for that moment, actually was brighter than the sun on Earth. So that's to tell you how violent these reactions can be. It is estimated that the explosion was actually more powerful than the atomic bombs dropped in Hiroshima and Nagasaki. But let's put it in perspective. The one that wiped out the dinosaurs, that was actually between 6 and 9 miles wide, and it left an impact crater over 100 miles in diameter. So let's go back and talk about the one in Arizona. That was about the size of a house and left a mile-long crater. The one that wiped out the dinosaurs, 6 to 9 miles wide, and left an impact crater over 100 miles in diameter. So huge. We do have our eye on a particular asteroid that we think is going to come pretty close to us, but just miss us. And it's called Apophis, or Apophis, depending on how you pronounce it. We pretty much don't know a lot about it, but we do know that it's going to come very, very close to us. Now, why do we study these things in addition to the danger they present? That is because these things can give us some clues based on their chemical composition, their shapes, how they've weathered over the years. Or I shouldn't say weathering because that's an Earth process, but how they've eroded or shrunk down over the years. It can give us some clues as to what the early solar system was like. Okay, if you're looking at this picture now, you're seeing the asteroid Eros. We actually were able to land a spacecraft on that, unmanned, of course, and so we were able to get some really, really, really valuable data there as to the composition of it. And again, it gives us so many clues as to what our solar system was like in its early years. So we do have space agencies working around the clock, looking up in the night sky or looking up in the sky for asteroids that present a threat. And for the most part, they've done a great job at identifying these things. But given that these asteroids don't often reflect a lot of light, sometimes they can be missed. The one that exploded in Russia was a complete shock, completely passed through every warning system. But again, we've identified one of them, Apophis, which is 270 meters wide, and it's going to pass very close to Earth in 2029 and again in 2036, because remember, these are following an orbital path like everything else in the solar system that goes around the sun. So, collision, you say? Well, let's take a look here. So this is the projected path. So again, a very near miss. In reality, this is a lot of distance between the asteroid and Earth, but in cosmic terms, not much at all. Um, as I say, it's thought to be pretty wide, 390 meters, and that's estimated from the brightness it gives off. And when it comes close to us, you can actually see it without the aid of binoculars or a telescope. So if it actually hits Earth in 2036, we're not exactly sure where it would land, and I'll show you that in our next slide here. But it would not be good. It would be the equivalent of about 1,600 megatons, which is many times more powerful than both of the atomic bombs dropped in Hiroshima and Nagasaki. In fact, one of the most violent explosions or eruptions on Earth was the eruption of the Krakatoa volcano in the South Pacific, and it would dwarf that. So there's the projected path if it actually did hit Earth. But again, remember that right now we are projecting that it's going to be a very narrow miss. So guys, I'm going to ask you now to go ahead and go on to the You Do activity. Okay, so the information that we went over in this video, you're going to be asked to recall and fill in the blanks. And I want you to try to do that from memory. When you're done, you can check your answers by either watching this video or going through the PowerPoint, and you can also do that to fill in the blanks on whatever you don't remember. But try to do it all from memory first and see how much you remembered. It's a good way to test yourself and a good way to study just a little bit. All right, and then when you're done with that, you're going to move on to the We Do activity, where in our public chat, you guys are going to talk to each other and try to come up with hypotheses about how this could happen. We actually found a meteorite in Antarctica in 1979. It was only 2 years old then, but it was found to have originated from Mars about 16 million years ago. So how on Earth does a chunk of rock from Mars end up on Earth? So guys, go ahead and when you're done with the guided notes, go ahead and have a little bit of a discussion about that in the public chat. What I want you to do is then individually write down the hypothesis that you think sounds most likely and go ahead and submit that on Canvas under the We Do section. You can use a Microsoft Word document, you can use a Google Doc, or any other program that you're comfortable with. Anyway, guys, that's all for today. Thank you so much, and I hope you have a great day, and I will see you tomorrow.